Hi guys, I am recording live in, what class is this? Fifth period, sixth period? Sixth period calculus. We're going live. Woohoo! All right, these are the problems they wanted worked out. So I'm going to record them as we work them out, starting with number 12. All right, here we go. Quotient rule. The derivative will be low, t cubed, d high, negative sine x or sine t. I'll put the negative out front. And sine t minus high d low. The derivative of that would be a 3t squared. Squeeze that in there. Draw the line and square below. What is t cubed times another t cubed? T to the 6th. I need more people to talk to me. And that would be the answer, except, can you see that we have a bunch of t's in common? Okay, so we're going to factor out however many I can factor out of all three. They have a t squared minimum in common. And the fact that there's two negatives, they might have also factored out a negative at the same time, but you don't have to. So, because they probably factored out the t squareds, I'm going to take out a negative and a t squared that they all have in common. And what will be left over? In the first group, I'll still have a t and a sine t. In the second group, I'll have a positive 3 cosine t. On the bottom, t to the 6th. And now I can cancel the t squared and the t to the 6th. They have 2 in common. If I take away 2 of these with 2 of these, that hopefully is how they wrote the answer. Although the negative out front, they may have left it multiplied out. I don't know which way they did it. So do you know by looking at the answer which way they left it? Did you all check your answers? You're really freaking me out right now.
I didn't know. I know.
Apparently, in the answers, they multiplied the negative out, but it wouldn't have mattered either way. My final answer would be negative t sine t minus 3 cosine t, unless you left the negative out in front with parentheses, all over t to the 4th. Okay, so that's number 12. Okay, at a glance, I don't see why this one would be difficult, except for maybe not knowing your unit circle. So the derivative is a quotient rule. So it's low, which is x, d high, cosine x, minus high, sine x, d low would be a 1. Draw the line and square below. This looks like a piece of cake. It must be the simplifying of the pi over 6 that goes in there next that messes you up. All right, so from here, now I have to plug in a pi over 6. So I'm going to be plugging in cosine of pi over 6 and sine of pi over 6. So let's just do the unit circle at pi over 6 real quick. Pi over 6 is this first guy. And the cosine is square root of 3 over 2. And the sine is 1/2. Remember, it's alphabetical. Okay, so plugging it all in, that's where your issue is, I know now. Okay, if I plug it all in, the derivative at pi over 6 would be pi over 6, cosine of pi over 6, which is square root of 3 over 2, minus the sine, which is 1/2, all over pi over 6 squared. Okay, so there's more than one way for us to simplify this. The first bunch of junk I can multiply straight across if I want to, okay? And that'll be pi root 3 or root 3 times pi. I never know which one to write first. So that's going to turn into the square root of 3 pi or pi square root of 3. I don't care which one you do first. On the top, and the bottom is a 12. On the bottom, square both of those. Square the top, square the bottom. So you're going to get pi squared over 36. And again, they like these weird answers on the AP exam. So now it's up to you. You can get a common denominator and subtract in the numerator and then divide by multiplying by the reciprocal. Or you could do that trick where you get rid of all of the fractions at one time. You have 3 different fractions. Find the common denominator of all of them, which would be 36. If you multiplied everything by 36, it would make this quick. Okay, so either subtract the numerator and get a common denominator, or I'm going to multiply everything by 36. Okay, so I'm going to multiply by 36 here, a 36 here, and a 36 here, because that will make all those fractions cancel. Okay? So now what's left, 36 divided by 12 is 3. So this whole term turns into 3 root 3 pi minus, over here 36 divided by 2 is going to be 18. So minus 18. On the bottom, the 36's cancel, and I get pi squared. You guys in your fractions. It's not the best location for that symbol, is it? I didn't know it was in the way. So it's 3 root 3 pi minus 18 all over pi squared. That's my answer. Okay, so in the back of the book, they end up factoring out the 3. On the AP exam, what will they expect on a question like this? Okay, that's very important. It all comes down to whether it's multiple choice or free response. Half your test is multiple choice, half your test is free response, and they count equally. 54 points, 54 points. Okay? So if it's multiple choice, that's why I say make it match the back of the book, because then you know how to do it, you know how to get to their multiple choice answer if it's not the same as yours. If it's free response, it's stupid to simplify. You should leave it unsimplified if it's free response. Don't waste time prettying it up, other than the fractions within fractions, because they don't care. They don't care. As long as it's mathematically equivalent, it's good. Okay? So it depends on the type of question. Now, to be honest with you, this would be a multiple choice question. This is not a free response type of question yet. Thank you for asking. Okay, so this one, they want to know where there is a horizontal tangent. Training you for the AP free response questions, when it says, and this would be a free response question. This is fair game right here. When they say horizontal tangent, you have to write derivative is 0. You should start with that. It also helps get your mind straight. That's what you're looking for. Okay? You get a point just for knowing how to justify things like horizontal tangent. And I want you to know, when I say you get a point, 1 point on the free response portion is the same as 1 question multiple choice. There are 54 points free response, and there are 54 questions multiple choice. Okay, same number of points. So a point is a lot. All right, so now we're going to find the derivative using the product rule. It's not going to be a difficult one to do. We have an e to the x and a sine x. The derivative of e to the x is e to the x. Derivative of sine is cosine, crisscross. So my derivative is, I know what the issue is on this one. My derivative is e to the x cosine x plus e to the x sine x. Now, again, if it's multiple choice, leave it like that and look and see if that's the answer. But this is why your book always factors things or gets a common denominator. If you go to set this equal to 0, you can't solve this without factoring first. Okay? So it's set equal to 0. Now what the heck do you do? Factor out the e to the x, and you're left with cosine x plus sine x. And I think we did one like this yesterday or the day before. Okay? Now set each factor equal to 0. Set e to the x equal to 0, and set cosine x plus sine x equal to 0. Okay? E to the x, when will that equal 0? Never. Happy E is always positive. Happy, always positive E. We like happy, positive people. Never going to be 0 and never going to be negative, so that gave me nothing, which is very convenient. Okay? Now this one is kind of intuitive. Move one of these to the other side. When does cosine equal negative sine? It doesn't mean that sine has to be negative. What this means is they are opposites. One of them's positive, one of them's negative, but it's not necessarily that cosine is positive. So now you look at your unit circle. Where on my unit circle do I have the same values for sine and cosine, but they're opposites of each other? Well, let's get to the quadrants first. Quadrant 2 and 4. And it's your 45-degree doohickeys. What do we call those? Count by fourths. 1/4, 2/4, 3/4 pi. So one of them would be 3 pi over 4. The other one would be over here, except they said just give answers between 0 and pi. Okay? More questions about that one? Now, I know that seems like it's kind of hard right now, but this is going to be like, oh, I know how to do this. Eventually, you'll get used to these, okay? As long as you keep on asking your questions, you're going to be like, oh, I totally know how to do that. I've seen this problem before. Like that E thing, it's going to show up a lot. E is a gift. If they give you e to the x equals something, if it's a negative or a 0, you're like, woo, I already know that's not possible. All right, what else you got?